In this unit, we're going to be talking about bonding, and today we're going to start with some foundational background information. Our learning objective is to be able to identify the type of bonding in a compound. And you know you got this if you can use the periodic table to identify elements as metals or nonmetals, and you know the difference between ionic bonding and covalent bonding. And this means that you know the types of elements involved in each one, and you understand what's happening with the valence electrons of the elements. So, what are bonds? A chemical bond occurs when valence electrons of two atoms begin to interact. Atoms bond in order to become more stable, and this typically means having a full outer shell with 8 electrons, and oftentimes this is referred to as the octet rule. Metals and nonmetals become stable in different ways and bond differently, but their goal is to try to get 8 electrons in their outermost shell. And so here you can see the chlorine has 8 electrons, the carbon has 8 electrons. Now, in order to kind of help us with this, we have to remember that the periodic table is organized in a way that we can quickly see where metals and nonmetals are on the periodic table. There's a dark line that runs through the periodic table, and this separates the left side, which has the metals, from the right side, which has the nonmetals. And I wouldn't worry too much about the metalloids. Just think of this as metals on the left, nonmetals on the right. And with this information, we're able to start thinking about how each individual atom behaves when it starts to bond. You see, in order for metals to become stable, metals are going to form bonds by giving away all of their valence electrons. So if I think of a sodium atom, sodium has one valence electron. It's in the first group on the periodic table. And if it loses that one valence electron, its outermost energy shell is going to change because this one electron is in the third energy level. If I lose it, then I'm only left with two energy levels, and now the outermost energy level has 8 electrons. One, two, three, four, five, six, seven, 8. This is now an octet. Nonmetals form bonds by gaining or taking electrons, and they're going to try to gain or take electrons until they have 8. So fluorine has 7 valence electrons in its outermost energy level: 2, 4, 6, 7. So it needs one more to get to 8. And if it gains that one electron, it will have 8 electrons in its outermost energy level, and it will become stable. So again, we can use the periodic table to determine how metals and nonmetals will behave. Metals will give away their electrons. Nonmetals will take electrons. And this is kind of the beginning to what you need to know. Atoms form bonds to become more stable. This means they want to reach an octet, to have 8 electrons in their outer shell. Metals are going to do this by losing valence electrons. Nonmetals are going to do this by gaining electrons. And again, our big tool here is using the periodic table to identify the type of elements.